Okay, so quiz 3A, relatively straightforward. We're talking about approval ratings after the State of the Union addresses and how much the approval rating changes. So we're told on average approval rating goes down by 0.11% with the standard error of 3.72% and that these changes are normally distributed. Then the question asks, how much would an approval rating have to increase so that it only occurs 1.1% of the time? So that's why once you draw the picture, it makes it really obvious. 1.1% is this little window here, so we need to find this little value right here, call it x if you want. So you do a basic little math thing. X minus the mean, which is negative 0.11, over your standard error of 3.72 is equal to, what is it equal to? 2.29. 2.29 is this z-score, what I've been referring to as z-star sometimes. So it's equal to 2.29 here. So basically here's your z-score formula. X plus 0.11 over 3.72 is equal to 2.29. Solve for x, you get that x has to be equal to 8.41%. So this value, x, is 8.4. So only 1.1% of the time will presidential approval ratings go up by 8.41% after the State of the Union address. Now the second question, which I've done out here, the second question asks, basically it tells you what are the odds that so far there have been 17 times in which a Republican gave the State of the Union and approval went up only 6 times. What are the odds of that happening? So again, we draw a table. Now, in order for approval rating to go up, that means that the change has to be greater than 0. So this little area right in here, convert that to a z-score, you get 0.0296, and then the probability of approval or probability of increase is 0.488%. So basically 50% of the time, almost, approval ratings go up. But now we don't want to see how much it happens. What are the odds of it happening once? We want to see the odds of it happening 17 times. So E sub x, so basically going back to the same thing that happened in quiz 1, your expected value is n times x, or n times p, sorry, so 0.488, which is what we count as our success, times 17, so you get 8.296, so that's your new expected value. SE of x, you need to convert it, so it's square root of n times p of 1 minus p, so that's going to be 17 times 0.488 times 0.5120, and you get your new standard deviation of 2.06. So now we need to draw a new table, new graph, because that doesn't apply. So we have our E sub x from here, which goes right in here, and then your standard error is 2.06. And we want to know what is the probability that less than 6 times it has increased. So we want to know this. But the key thing here is you have to use 6.5. Remember, it's Professor Lin's rounding thing that if it's less than 6.5, it's going to round to 6. So that's why you have to add that 0.5 in. So when you're converting your z-score, or when you're calculating your z-score, it's 6.5 minus your SE over 2.26. Need to be consistent here. 2.06. And that, you find your z-score, and from there you get that your percentage of the odds of what happened to the Republicans, which is it only increasing 6 times, the odds of that happening are 19.51%. Again, watch out for your rounding.